All right, 5. Again, we're going to start by multiplying A and C. 2 times negative 4 is negative 8. If we're multiplying to a negative, then we need a positive and a negative. So I'll have to play with that in a minute. Our factors of 8 are 1 times 8, and then 2 times 4, and that's it. So if I'm going to add to negative 7, I'm going to need a positive 1 and a negative 8. That's my combination. 2x squared goes out front. Negative 7x becomes positive 1x minus 8x. And then minus 4, and we're equal to 0. Now we're going to cut our problem in half. The first two have x in common. When I take an x out of 2x squared, I'm left with 2x. When I take an x out of 1x, I'm left with 1. Negative 8 and negative 4 doesn't have a negative in common. I want that negative there. 8 and 4 I can divide by 4. So I'm dividing by negative 4 here when I'm thinking through this. Negative 8x divided by negative 4 is 2x. Negative 4 divided by negative 4 is positive 1. Stuff on the outside in one set of parentheses. Our other sets of parentheses should match, and we just write it once. Now, what we do now is set each of these equal to 0 and then solve those little baby equations. So if you haven't done that yet, go ahead and pause the video. Set those equal to 0 and solve. So what you should have been doing there is adding 4 over for this equation. And then for 2x minus 1, or 2x plus 1, we need to subtract that 1 over first, and then divide by 2. So we have x equals negative 1/2. We always want to check by graphing. So I'm going to input my original problem, 2x squared minus 7x minus 4. Oh my. And I'm going to hit the home button so I'm back to a normal screen there. And take a look at where this crosses the x-axis. We don't care right now where it crosses the y-axis. That's for next week. So where this crosses the x-axis is the negative 0.5, which is negative 1/2. And 4. And that is perfect. That's absolutely right. So our math is right. We've shown that that is a situation from graphing and by factoring. Okay, number 6 I'm going to do because we get a lot of questions on this one. There are only 2 terms here. And if we have 2 terms, we're either going to do a GCF problem, greatest common factor, or difference of squares. When I'm looking at my numbers here, 2 and 10 are not perfect squares. So I cannot do difference of squares here. I just need a GCF. So I'm looking for the biggest term that I can take out of both. 2 goes into 10, so I know I can take out a 2. And I have an x squared and an x, so I'm going to be able to GCF out a 2x. When I take out greatest common factor, the rest is, the leftovers are, they're going to be the same number of terms in my parentheses as I started. So now I'm going to kind of think division here. The 2's are going to cancel. X squared divided by x, that first term I'm just going to be left with an x. With 10x, when I divide by 2x, the x's are going to cancel, and I'm left with 10 divided by 2, which is 5. So So I don't have two sets of parentheses like I did in the last problem, but I do have two terms I can set equal to 0. 2x is equal to 0, and so is x minus 5. That's multiplication, just like we had multiplication here in that last problem. So I can set both of these equal to 0. Just like I did with all the rest of the problems here. Zero over 2 is 0. If you're not 100% sure, throw it in Desmos and calculator. Just move it, not 5 over. We can double check this one in Desmos as well. I know it looks a little funny, it looks a little different than the last problem, but it was just 2x squared minus 10x. And we're looking for it to cross our x-axis at 0 and at 5. And it does. If you're struggling with the factoring, at the very least, put the problem into Desmos and see if that helps you. All right, I'm going to do number 7 as well, I think. So here we have 1 times 6, another factor tree for 6, and of course our factor tree for 6 is 1 and 6, and 2 and 3. And 2 plus 3 is 5. So I'm wanting to add to 5, multiply to 6. My x squared stays the same. I'm going to change my 5x to 3x plus 2x. I'm going to leave my positive 6. I'm going to cut my problem in half. My first two terms have x in common. When I divide out an x, I'm left with x plus 3. Go ahead and pause and see if you can finish the problem. All right, hopefully what you did was then see that 2 and 6 have 2 in common that you can divide out, and you're also left with x plus 3. Those parentheses should always match. And then your two little parentheses that you're left with down here, x plus 2, and your x plus 3's. And that gives you, since we don't have any numbers in front of our x's, we can just switch those signs. X equals negative 2, x equals negative 3. Let's check if it does most as well. X squared plus 5x plus 6. I'm not putting n equals 0. When you put n equals 0, it takes it from a nice parabola. It still gives you the right answers. But it takes it from looking like a nice parabola to just giving you those solutions. I would rather see the parabola. So I want to see the parabola the way it is intended. Don't click on that minimum value. Don't click on the y-intercepts. Those are important to us. We will definitely work with them later. But right now we're just working on x-intercepts. So that graph crosses the x-axis at -2 and -3. If you need more examples, click on the next